Hi everyone, in this video we are going to discuss problem number 3, the longest substring without repeating characters from Leetcode, right? So it's a medium problem and let's read the problem description. Given a string S, we need to find the length of the longest substring without repeating characters. And obviously you know what a substring is. It is a contiguous array of characters, right? There cannot be any gaps. Yeah, and let's go over all these examples. Example number 1, the given string S is this one. The characters are A, B, C, A, B, C, B, B, and the output is going to be 3. And here is the explanation. The longest contiguous array of characters that we can find is of length 3, which is ABC, right? Here you can find ABC. It's not necessary that you will find only one such subarray, right? You can also say it is BCA. You can also say it is CAB. You can find another ABC over here, right? So you can have multiple subarrays having the same longest, length. That is totally possible. Okay. Now we are not interested in finding. We are not asked to find the subarrays themselves. We just have to find the length. That's more than enough. Okay. What about this example? Input is this string, which is B, 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 B 5 times, okay? So clearly the letters are repeating. Therefore, the longest we can find, the longest subarray with no repeating characters that we can find is B, right? Hence the output is 1, okay? Check this example, P, W, W, K, E, W, right? Here the output is 3 because the longest one we can find is W, K, E, or you can also say KEW, right? Okay, when it is an empty string, naturally it has to be, the output must be 0, right? Now, please pause the video here and try to solve this problem on your own. Definitely you can find a solution which is a brute force solution, okay, with quadratic time complexity, right? You will just have to consider all possible substrings, literally everything. You consider all possible substrings and check whether they have any repeating character or not. If not, then measure its length, and of all those lengths, find the maximum. That is definitely going to work, right? Quadratic time complexity is obvious, but can we solve this in linear time complexity? Think about it. Let's head over to whiteboard and see how to solve this. So we are taking this 2-pointer approach, right? So we have 2 pointers I and J is always going to run ahead of I, right? I'll tell you exactly how. Okay, initially both I and J are at the 0th index. Now we are going to run J. I is going to run slowly. Okay, J will run faster. We are going to run J. How exactly we are going to run J? We are going to run it as far as possible till we hit the first repeating character. Okay, so J is here now. Okay, I is at 0, J is at 1. Okay, and what is this substring AB? Is there any repeating character? No. What is its length? 2. Okay, let's note it, right? And then again, increment J. Don't do anything about I. Increment J. Yeah. So what is this substring ABC? What is its length? 3. So let's note it down, right? Now we are going to replace our maximum length with 3. Yeah. So J is here. Now again, increment J. Now J is here, 0, 1, 2, 3, third index. We have a repeating character. The first time when J is hitting the repeating character, that is when we are going to increment I. Usually we are going to increment I by just one number, but it can vary. I'll tell you in what condition it will vary, right? So we increment I by just one number. Now look at this substring. It's of length 3. We have already had a substring of length 3. There is another substring of length 3 with no repeating characters. Fine. Now let's increment J. J is here. Now there is a repeating character, right? So what are we supposed to do? We will lock J there, right? Whenever you hit the first repeating character, we will have to lock the second pointer J, the pointer which is running fast. Okay, you will have to lock it. You will have to increment this left pointer I. You increment it by 1. Again, we have this substring of length 3, right? It is of same length. We have already seen twice. Okay, so same length 3. and this is a substring with no repeating characters. So we are going to increment j. Now there is a repeating character, so we have to log j. Now increment I by just one number. I is here. Again, another substring, okay? Another substring with exactly 3 elements, no repeating character. Then increment j, j is here, right? Now this is when you will notice that we are going to increment I 2 times back to back, right? The moment you hit the first repeating character, we are going to lock the j pointer, the right pointer in its place. We're going to lock it. Only I we are going to move, right? I we are moving here. Now look at this substring. Yeah, we do have repeating character, okay? So again, I'm incrementing I, okay? What is it? It's a substring of length to CB. There is no repeating character. So now we are allowed to move j, right? J is here. Now we do have a repeating character. If you have repeating character, what are we going to do? We are going to keep incrementing I. We are going to lock j in its place. We are going to keep incrementing I until we don't find any repeating character or until we hit the end of the string, right? So we are incrementing I is here. We still find repeating character BB, right? Now we are incrementing I reached the end of the array, sorry, the end of the string, right? So once I reaches the end of the string, that indicates that we have completely scanned the given string, all its characters from left to right, okay? And one thing you would have noticed, both the pointers I and j, they moved right exactly once. Neither I nor j went back and started over, right? It never moved left at any point of time. You can check this. Let me redo all the various positions of I and j. You can see always j is moving right, I is moving right. At no point of time, j or I is moving left. It's always moving right. And this particular approach is called as sliding window approach. So it's like a proper linear scan, okay? So that is why when we write algorithm for it, it is going to be running in linear time complexity. The brute force solution is to consider all possible substrings that is going to be in that is going to be running in quadratic time. This is going to run in linear time, right? So this is the idea. Let's code it out. So we need to have 2 variables to represent these 2 pointers, I and j. We call them I and j only. And initially they both are at the 0th index, obviously, right? And we need another variable to capture the maximum length of the longest substring without repeating characters, okay? So we are starting with these 3 variables. Now we are going to use Q data structure. I'm going to use the regular Python list as Q data structure, and we are going to enqueue by using the append method, and we are going to dequeue by using popping method, but we have to carefully pop off only the 0th index, right? If you're using the typical popping method, it will always pop off the last element, then it is going to act like a stack. We don't want to use a stack here, we want to use a queue here. So we will have to pop off the element at the 0th index, okay? So we will initialize a queue here, to which we are going to add and remove elements, more formally enqueue and dequeue, okay? So we'll start a while loop. While I is less than length of the given string. By the way, s is the name of the given string, okay? S is the name of the given string. So while I is less than length of the given string, okay? Because when this condition fails, then we know that we have completely scanned the left pointer, I has completely scanned this entire string from left to right. Then there is nothing more for us to do. We are done with the problem, right? So as long as I is less than length of s, the problem is still incomplete. It is in progress, yeah? Okay, so when I is less than length of s, we will have another inner loop, okay? While j, even the right pointer j, the pointer which is running fast, okay? The right pointer j is supposed to be, of course, it has to be less than length of s, right? the right pointer j is less than length of s. Okay, and not just that, and sj is not in Q. If Sj is not in Q, then it means that we are going to add that particular element to the queue. We are going to enqueue it. And if Sj is already in Q, then it means that we shouldn't be going ahead with this while loop. We should be just fixing j. We should only let I increment, right? Okay, so if Sj is not found in Q, then what are we going to do? Q.append of Sj, and of course we are going to increment j by one number, right? And we'll keep on incrementing j value till we hit the end of the string or till we find the first repeating character. The moment we find the first repeating character, we are going to exit this while loop and then immediately check the length of our queue. We are going to check the length of our queue. If the length of our queue is greater than the maximum length, so this is where we are capturing the maximum length. So every time we form a bigger and bigger queue of non-repeating characters, we are going to keep on updating the maximum length with the value of the length of the queue itself. So maximum length is length of queue itself, right? And once we are done with this, we are going to pop off the 0th element. That is basically dequeuing, right? Q.pop of 0. We are removing the 0th index, and of course we will have to increment I, right? Then again, the while loop continues till we hit the end of the given string. Then finally, we are going to return maximum length. So let's see how our algorithm works. Let's now go back to Leetcode and type our code. So we need to first introduce those three variables, I, j and maximum length. Initially they're all equal to 0. And let's initialize this queue data structure, okay, which is basically an empty list. Then we have this outer while loop while I is less than length of s. S is the name of the string. It's clearly given over here, right? So while I is less than length of s, and then we have inner while loop, j is also less than length of s, and sj is not to be found in the queue. It means we did not hit the first repeating character yet. Okay, if that is the case, what are we going to do? We are going to enqueue that particular element by appending sj, right, into the queue, and we are going to increment j value by 1. And the moment we exit this particular loop, okay, because we found the first repeating character or we have actually hit the end of the string, either way, right? Once we exit this inner while loop, we are going to immediately check the length of the queue, because that is going to indicate the length of the longest substring with non-repeating characters. But this length is going to keep on getting updated. We are going to capture its value using the variable maxlen, which we initially took it as 0, right? So maxlen is updated to be what? The new length of the queue, right? And then we are going to remove that element, the 0th element in the queue. Okay, so we are going to dequeue here by using the pop method. We are removing the element at the 0th index, right? We are going to keep on removing the element, popping off the element at the 0th index till the queue is free from repeating characters, right? And then we are supposed to increment I value, okay? And we'll be exiting this outer while loop once I is going from left to right fully. And like I told you, this is called a sliding window approach because both I pointer and j pointer, they are moving left to right exactly once, okay? So it is going to be clearly a linear solution, and we will have to return maximum length. Let's try run this and check how it works. It works fine. So let's submit our solutions and see if it clears all the test cases. Okay, it's accepted. Even our solution is fine. Hope this particular solution is clear. Thank you for watching.